In this video, we're going to do some examples where we use those formulas that we've worked out in the last video. So we need to find the length of the chord shown here. So what I'm going to do is I'm just going to go back and check what my equation is for that. So length of a chord, it is 2r sine theta on 2. All right, let's use that. So chord, what are we going to, it's what, CB? CB is 2r sine theta on 2. So we're doing 2 times 4 times sine of theta on 2, so it's 30 on 2, so it's 15 degrees. And if I do that, and I just get out my calculator, so I've got 8 times sine of 15, my calculator tells me that that is 2.071 centimeters. Seeing as we're working centimeters, not too bad. Length of the minor arc. Okay, so the minor arc is from C to B around the edge of the circle, so we'll just call it this curvy L. And I know that it is just theta times the radius, provided I'm working in radians. So I do 30 times pi on 180 times by 4. So what? Get rid of that, get rid of that. So it's pi on 6 times 4. Let's see what my calculator says that is. Pi on 6 times by 4. That is, so I mean, you know, it's 2 pi on 3, but if we wanted to do a measurement kind of thing with decimals, we get 2.09 centimeters. All right, now we need the area of the major segment. So the major segment, that is, so here is the minor segment, right? Just in here, just a little bit. So the major segment's the rest. What I might do is I'm going to get the area of the minor segment and then just take that away from the total. So area of minor segment is, so area of the sector. So what do we got? Just go back and have a quick look at what my area of my sector is. So, or a segment, if I'm doing radians, I've got half r squared theta, take half r squared sine theta. I feel like we could do a bit of, factoring, couldn't we? We could take out a factor of half r squared, and we just get theta take sine theta in here. That might be nice, so we just do a bit of factorization. So that is provided we're doing radians. So we've got half r squared times pi on 6, take away sine of pi on 6. So sine of pi on 6 is just a half, funnily enough. So we've got half times 4 squared pi on 6, take a half. Now, so we get what? That's 16 times a half is 8, so we get 8 pi on 6, take 8 on 2, which is 4. So if we just put that in our calculator to get an approximate answer, we get 0.19 centimeters squared, and we need to take that from the total. So area major is just the total, pi r squared, take away this 0.19. So if we put that in, so pi times 4 squared, take away our answer from before, we get 5.01 centimeters squared. Let's have a look if that's what I got elsewhere. Looking pretty good. Ooh, looks like I've got a bit of disagreement here, but not by a lot. I'll